is a supermassive object, and light doesn't escape it. Light does not leave it. Okay? So what I think is probably happening is distortions. Okay, so if you look at a black hole, black sphere, through a telescope, you may not see that it's a sphere, that it's a sphere like any other star or planet. And I think the only reason for that is, one, the mass of black holes are quite large, and two, all light and all energy that come anywhere near a black hole are absorbed. So again, when you're looking at through a telescope, that's the sense that you have, is a visual sense, which is light, and that's what you're looking at. So whatever shape it looks like or appears like, whatever it does to the background around it, all those things like that is almost irrelevant, because again, this object, this sphere in the universe, is absorbing light at a ferocity as great as the star that it came from was expelling light and heat. Okay? So this is a sphere, not a hole. This is a sphere. And these spheres are born out of the life cycle of stars. And what happens really on a simple level is a star, through its entire life, through millions and billions of years, is composed of fuel that it's expelling. It's composed of fuel and expelling heat. It's burning in space. It's burning up all of that heat. Okay? Now don't try to imagine it like it's a bonfire. Okay? Because what happens on the surface of the Earth, the physics of that are much different than what happens in outer space. But it is a giant ball of fire, and for billions of years, it's burning its fuel and it's expelling heat. It's expelling light. It's using all of that energy up at enormous temperatures. What happens as it gets closer and closer to its star death is that heat is gradually reducing until it reaches a point in which the fuel is totally gone and the heat is totally expelled. In the case that you have a supermassive star that ends up becoming a black sphere, black hole, you have a supermassive sphere now that has used up and expelled all its heat, and is basically a giant sphere in the sky of matter that is now composed of just matter. It's no longer composed of any electrons. It still has structure. This is key. And this is why the singularity is a false notion. There is no such thing as an infinitely dense piece of matter. Protons and neutrons come together and they are pressed together just like any atom, just like an atom is pressed together on Earth, just like an atom is pressed together at the core of the Earth. Okay? Those things are pressed together. And in the same way, those structures in the black sphere are pressed together. They're still pressed together and they still have their structure. They've just expelled all of their electrons, all of their heat, all of their energy. It's gone. So, now, where you had a giant stellar body that consisted of enormous temperatures, now you have the opposite. Now you have a giant, massive stellar body that its temperature is absolute zero. This has gone from a super hot, burning stellar object to the exact opposite, a super cold, freezing stellar object. And anything surrounding it, especially light, is absorbed stronger than any other absorption process that exists in the universe. So, expelling heat, absorbing it. You expel heat for a billion years, and then you absorb heat for a billion years. And this is a black sphere. And this is the birth and the life cycle of a star. So where you had those immense temperatures, now you have those immensely cold temperatures, the complete lack of heat, lack of energy, and now the black sphere is absorbing everything that comes near it, everything within 100 million miles, everything within a light year of this black sphere is being absorbed. Matter, but mostly energy. I take that back. I don't know if matter is being absorbed. That's almost a different subject. But the matter remains the same. The energy is gone, and then it begins the entire process of being absorbed. So these black spheres in the sky, these are enormous objects that were once stars, incredibly hot, and are now incredibly cold, and they're in the process of absorbing everything that comes in their way. Now, evidence-wise, I don't know. Black holes, spheres have been a mystery since their founding. So, if you want to argue it, go, feel free. And if you want to think you're presenting evidence because you're presenting some visual thing from a telescope, then feel free. But again, any kind of shape that you might see from this, those things are all distortions from the fact that it's powerfully absorbing heat. Now, since there is no such thing as gravity, what I suspect is mass, just like here on Earth, kind of like magnetism, mass does attract energy. So I suspect when they're trying to say that it has this immense gravitational pull in the singularity, and that everything that it comes close to, everything that comes close to it is being sucked in. What that is everything that has a tiny, tiny bit of energy, anything and everything, is absorbed. Okay? I think the easiest way to think about it, and again, this is just totally as something to help you form a picture in your mind about it, is a giant piece of charcoal. On the surface of the Earth, when you have a fire that eventually burns out, it ends up being carbon and other minerals that don't end up getting burned in the combustion process. But those things, if it wasn't for the ambient temperature, those things would also be at a very, very low temperature. Because those were things that could not absorb heat. And all the heat was expelled, and you're left with essentially a shell of carbon. This is on the surface of the Earth. Like charcoal, for example, and those things are incredible for their ability to absorb not just heat, but anything. They absorb, okay? And that's probably the best way to think about a black black hole is that it's the shell of a star that has gone through its life cycle of expelling heat. It's now a giant piece of absorbing charcoal at the lowest temperatures that can possibly exist, absolute zero or more, and now is in the process of taking in everything from the universe that comes in the range that it can capture. And this is what a black sphere is, a black hole. And over the next billion years of that life cycle of that black hole, it's absorbing and absorbing and absorbing that energy, absorbing it up, and probably some mass too, I imagine, and till it reaches a critical point, and essentially kind of like a fire, all of a sudden it turns on, and now it's a star. Okay? And so it's this back and forth, the circular nature of the star's life cycle. It goes from the immensely hot object in the sky to the immensely cold object in the sky, immensely hot object in the sky, immensely cold object in the universe. And that's what it is. So, not a hole, it's a sphere. And I hope from here on out that in your quest for knowledge that you don't think of those things as black holes, because they're not. They're black spheres. So next topic is, well, I don't know what the next topic is, but rest assured it'll be a great one, because it's me, Lenny. All right? So thanks for listening, and I'll see you again.